Ladies and gentlemen, fans of calculus, welcome to this video lesson that's going to go over what we call the fundamental theorem of calculus, sometimes known as definite integrals. And we're going to do these even number problems in this set 2, 4, 6, 8, and 10. This first one we're going to look at is problem 2. We have the integral from -2 to 3 of quantity x minus 5 dx. And we could take this x minus 5 and do u-substitution. But probably it'd be even a little easier to just directly integrate. So the integral of x dx is going to be x squared over 2. And then the integral of -5 dx is going to be -5x, or minus 5x. And we're going to evaluate between -2 and 3. So now we're going to plug in 3 for x. So we're going to have 3 squared over 2 in the place of x, minus 5 times 3, and then we're going to subtract out. Now in this lower boundary I'm going to put a big parentheses to make sure we're taking care of everything. So we're going to take in -2 in the place of x, square it, divide by 2, minus 5 times -2. And now it's just a matter of simplification. So 3 squared over 2 is going to be 9 over 2. Next we have minus 15, which is going to be minus 30 over 2. And then inside parentheses, we're going to have this -2 squared over 2, which is going to be 4 over 2. And then we have this minus 5 times -2 is going to be plus 10 or plus 20 over 2. And now what we get here is we get 9 minus 30 is going to be -21 over 2. And then we're going to have minus 4 plus 20 over 2. So minus 24 over 2, which is going to simplify to -45 over 2. And that is going to be our answer. Now it says confirm using your calculator. I'm not going to confirm for all of these, but just show you how it can be done. If we go here to take go to math, we go to finite integral, which is 9, and we're going to go from -2, integrate from -2 up to 3, and we're going to have x minus 5 and dx, which we get -22.5, which is the same as -45 over 2. Let's see, math. We go to fraction. See, exactly the same thing. All right, let's go on to problem 4. Here we have a situation where we could expand this out, but I'm going to go ahead and do a u-substitution for this quantity 2x minus 5. So we're going to set let u equal 2x minus 5. And when we do that, we're going to have du with respect to x is going to be equal to 2. See, that's du, okay? And we cross multiply the dx, we're going to have du is equal to 2 dx. So dx is going to be equal to du over 2. And so now we're ready to come in and make this substitution. And working below, we're going to have this u in the place of this quantity 2x minus 5 squared. In the place of dx, we're going to have du over 2. Now one thing we got to be careful about is the limits of integration. We have changed things here, so we're going to have to, with u, we're going to have to change our limit of integrations to be consistent. So if we plug in 0 in the place of x, we're going to have u So 2 times 0 minus 5 is going to be negative 5. And now if we place 2 in the place of x, we're going to have 2 times 2 minus 5, which is going to be negative 1. So just kind of working below here, what we have here is we have the integral of u squared is going to be u to the third power, and we're going to take 2 times 3, because we're going to divide by 3, and 3 times 2 in the denominator is 6, so we have u cubed over 6, and we're going to evaluate that between our adjusted limits of boundaries of integration, which is going to be negative 5 to negative 1. And now just kind of working below here, we're going to substitute in negative 1. So we're going to have negative 1 cubed over 6, and we're going to have minus, we're going to have, make the big parentheses here, we're going to have negative 5 cubed over 6, and really that's going to be it. So let's just work this below. What we're going to get is negative 1/6, and then we're going to have negative 5 cubed is going to, so that's going to be minus negative 125 over 6, which is going to be the same as 124 over 6, which is going to simplify to 62 over 3. And so that's going to be our answer for this particular problem. Let's do the next evener problem, which is 6. We have the integral from negative 2 to negative 1 of x minus 1 over x squared. So what I'm going to do first on this one is do a rewrite into what I like to call calculus-friendly form. And so we're going to have x definitely, and this 1 over x squared is going to be x to the negative 2 power. And then that's going to be dx. And so now we're ready to integrate here. So we have the integral of x is going to be x squared over 2, and then we're going to have minus, we're going to have this x to the negative 2 power becomes x to the negative 1 power, and we're going to divide by negative 1, which is the same as really changing the sign here. And so just kind of working, and I'm going to put the limits here from negative 2 to negative 1. And just working ahead to the right here, we get x squared over 2, and we're going to have plus 1 over x, and we're going to evaluate that between the boundaries of integration between negative 2 and negative 1. And so now just working below here, we're going to have negative 1 squared over 2 plus 1 over negative 1 minus, I'm going to take negative 2 here, negative 2 in the place of x squared over 2 plus 1 over negative 2. And just working below here, we're going to get 1/2 minus 1, what did it say? I'm going to put minus 2 over 2. I'm going to keep this in halves for now. And then we're going to subtract out what we have here. Well, we're going to have negative 2 squared, which is going to be 4 over 2. So we're going to have 2 minus 1/2. So that's going to be minus 3 over 2. And so we're going to get 1/2 minus 2 over 2 minus 3 over 2. So for this, we're going to get negative 4 over 2, which simplifies to be negative 2. And so negative 2 is our correct answer for number 6. Okay, the next even number problem is 8. Now number 8, I recognize that there's a shortcut to solve this problem, but I'm going to kind of work out the, I'm going to pretend like I don't see the easy way to go to the solution to this and just work it out here straight up. So what we have here is, I'm going to rewrite this integral from negative 2 to 2 of x to the 1/3 power dx. And the integral of this is going to be x to the 1/3 plus 1 is going to be 4/3. And then we're going to divide by 4/3, which is the same as multiplying by 3/4. And then we're going to evaluate that from negative 2 to 2. And I'm just going to continue work below. So we have 3/4. We have x, and it's going to be 2 in the place of x. We'd have x, the thirds is going to be cube root of 2 to the 4th power minus, we're going to take, put this parentheses, 3/4. We're going to have cube root of negative 2 to the 4th power. Okay, so that's what that's going to look like. And then so what we're going to get here is 3/4, I'm going to change, of 2 to the, we'll say this is 4/3 power minus 3/4 2 to the 4/3 power. Now you see you're subtracting out the same thing, so we're going to have a net of 0. Well, the thing about it is, with this particular problem, if you were able to spot what kind of a function this is what's known as an odd function, which means that you have rotational symmetry about the x-axis, about the origin. So if we go ahead from negative 2 to 2, we're talking about the area under the curve. So this is what the function looks like. This is going to be the cube root of x. So we'd say f of x equals cube root of x. So this area down here between negative 2 and 0 is the same as the area here between 0 and 2, but on opposite sides of the x-axis. So these areas will cancel each other out. So a recognition of the type of function can a lot of times, or sometimes, lead to an easier solution. So let's go on to the next one in this exercise set. We have this number 10, which is the integral from 0 to 3 of x minus 2 dx, the absolute value of quantity x minus 2 dx. And so this is one where you really have to work things out and kind of see where things are to figure out what's going on. And to do this, I'm going to make a quick little sketch of this function here. So what we have is, if we set this equal to 0, x minus 2 is equal to 0, and solve for x, x is equal to 2. So 2 is going to be like a critical number in its evaluation. So the function, this x minus 2, is going to go like this, and then it's going to come up like this. And then, but what's happening below the x-axis, we have the absolute value, and so this piece between x equals 0 and x equals 2 is going to actually be up like this. And so what you're really looking at is this area here plus this area to the right. So you have two separate pieces of this integral between 0 and 2 and between 2 and 3. And so what this is going to be is, it's going to be negative of what this area is in the bottom. So what we're going to do is we're going to take, that's going to be equal to the integral from 0 to 3 of x minus 2 dx. However, we are going up above the x-axis. So what we have to do is we're going to make this negative out front, like this. So the negative out front is what accounts for this function x minus 2 being the absolute value. And then we're going to have to add this area here between, it's going to be negative with the boundaries between 0 and 2. And then we're going to take this area above the x-axis between 2 and 3. And we're going to have here x minus 2 dx. And so now it's a matter of taking our boundaries, integrating, and take the boundaries of integrations. We're going to have equals negative. We're going to have, I'm going to put this in parentheses, we're going to have x squared over 2 minus 2, and that's going to be that, and we're going to go between 0 and 2, and then we're going to have plus, we're going to have x squared minus 2, put this in parentheses here, minus 2x, oops, let's get this right, minus 2x, there we go, minus 2x, and we're going to evaluate this piece between 2 and 3. And so now it's a matter of plugging in here. So we're going to take in the first, plugging in 2, so we're going to have negative, we're going to put in 2 squared over 2 minus 2 times 2, and we're going to add this next piece here, which is going to be 3 squared over 2 minus 2 times 3, and now we're going to plug in 2 and subtract out this 2 here, so we're going to have 2 squared over 2 minus 2 times 2, and it's just a matter of simplification from here on out. So we're going to have negative, we're going to have in parentheses here 4 divided by 2, which is 2, minus 4 plus, we're going to have 9 halves minus 6 minus, we're going to have this 4 over 2, or 2 minus 4. So you're just working to the right here. We're going to have negative 2, so that's going to be positive 2, and we're going to have 9 halves minus 6. Now 9 halves minus 6 is the same as 9 halves minus 12 halves, which is going to be negative 3 halves. So we're going to have plus 3 halves, or minus 3 halves, because that's 3 halves, plus negative 3 halves, minus, we're going to have negative 2. And so that's going to be equal to, just working the right here, we're going to have 4 halves minus 3 halves plus 4 halves. So for this, we're going to get 5 halves is going to be our answer. And then we can go ahead and try this once by putting it in the calculator. There are a lot of things involved here, so let's go ahead and do this. We have the integral from 0 to 3 of the absolute value. I'll put second catalog enter. We're going to have x minus 2, and we're going to go to dx here, and we should get, yes, with the little TI idiosyncrasy rounding error, so 2.5, 5 halves. So it checks out. So anyway, that's the even number problems worked out. I hope this one helped to you. Good luck, and thanks for viewing.